6.6, Section 6.6, Chapter 4, Part 2 video. We will pick up where we left off at the end of Part 1, and that is doing quadratic regression. So find the formula for the parabolas through the points 5, 5, and 8, 9. And what I alluded to on the previous video was if they only give you 2 points, well, you got to find a third one in order to do a quadratic regression. So if you look at the x values, this is over 3. So if I go over 3 here, so 5 take away 3 is 2, and that would be 2, 9. It has to be the same y value as this point over here, but at 3 units to the left of 5, 5. Okay, so let's write our points out. 2, 9, 5, 5, and 8, 9. And we're going to do a quadratic regression again. All right, so clear. So second plus 4, enter. Stat, edit. Make sure we're in 1, 2, 5, and 8. Let's see, 2, 5, 8. And let's see, 9, 5, 9. 9, enter, 5, enter, 9, enter. Okay, so stat, calc number 5, quadratic. I tend to store mine in y1. It's just out of habit. And 2, it writes the equation in the form that I need, as opposed to looking at it like this, which it gives me A, B, and C. But you just got to substitute A, B, and C in for the values up there. So here we go. So just do this. Darn it. Let's go here. There we go. 0.44. So I got 0.44x squared minus 4.44 x and 16.11 plus 16.11. So that's the equation that would derive from this. That's going to be my last regression that I'm going to physically do on the calculator portion. I will set up the equations except for the kind of the last two, which are word problems, so we'll need to do that. All right, so on this one, again, I'll show you how to get the 3 points. So we know that we have 2, negative 2, 1, right? And then 0, negative 1. So let's see. So if this is negative 2, and I go 2 places because that's 0, so this would be negative 4, and it would be, so negative 4 comma negative 1, 2, 1, and 0, negative 1. If you look at this on the axis, they're 2 away from the vertex, right? And because they're 2 away, they have the same y values, right? So you can plug those in and do the quadratic regression. I've done it enough that you've got enough videos to know the key steps in that now. All right, so this one, you type all of these in and you perform a quadratic regression. That one's not too bad. It just, you got a whole lot of points to type in. So just make sure that you're good on that one, okay? You don't have to worry about, things are already in terms of thousands or tens of thousands of dollars. So don't worry about that. They're not asking. They just want you to take these numbers, plug it in L1, right? This one, L2, perform a quadratic regression, put the formula down, right? No big deal. And 1 to 2 decimal places should be fine because they're only one here. So that shouldn't be a problem. Just make sure that you round correctly. Biggest thing that I've seen looking at problems or issues with these questions that y'all are missing is rounding issues. So make sure that y'all take care of that, okay? All right, so here we go. We got this one, and so okay. So recliner price if the table fill in. Let's see. So we multiply these recliner price and demand. So use the quadratic regression to find the quadratic function for revenue. Okay, so we've got to do revenue as a function of the price that best fits. So, all right, so let's kind of here's my X and here's my Y. So, got to make sure that we multiply those two together. Let me get my calculator real quick. So, all right, here we go. First things first. 399 times 62 would be 24,738. Okay. 499 times 55 would be 27,445. 599 times 47 is 28,153. 699 times 40 would give me 27,960. 799 times 34, 27,166. So we've found the revenue. Now we've got to type these into our calculator. So that's 399, 499, 599, 699, 799. All right, so let's go ahead and do this. So let me clear this out. Second plus 4 wipes all my list away as far as it takes and cancels out. So we are 399 up to 799. So 399. Back, missed that 3. 499, 599, 699, 799. All right, so we should have 24,738 and 27,445 and 28,153, 27,960, 27,166. Okay, there we go. All right, so that's all in there. All right, so second, no, not second tray, sorry. Take that off. Stat. Let's go back to that. Okay, so stat calc. I've got those all in. I don't know why I hit second there. It's just stat calc, which is over to the right one. And it's number 5. Um, again, store the equation in y1, which is vars, arrow, enter. We need that because we're going to do something with it. Okay. Hit enter. And then there's my equation. Okay. Um, negative 0.0565 round to 4. So negative back 0.0565 x squared. Make sure you're at 4 places on that. Okay. 72.9981. 474, 9, 47.8546 is your 0.8546. So that's the equation. Okay, so what I'm going to do is it says, according to the quadratic function you found in B, what price should the store charge for the recliner to maximize revenue? Okay, so let's go and let's just hit graph. I don't have a clue what my limits are, so I'm just going to zoom 6, right? And then zoom fit. All right, so we know we're not out wide enough, so let's go. My X values is price, right? So we know that we ought to be, let's just say 1,000. Okay, and we'll go negative 100, and we'll step it by 50. Okay, and just hit graph. Okay, zoom fit. There we go. So I needed zoom fit to be able to scale my Y to my X's. So I need to open it up just a little bit and maybe give a little bit more headroom on the top for my Y value. So I'm going to go 1500. Y max is 28,000, so I'm going to go 30. Just enough to give, headroom up there. I'm going to move that about 2,500 just for grins and giggles, so it won't make it look like a solid black line on the y-axis. So here we go. Second trace 4 because it's a maximum, right? So here we go. Enter. 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 So they should charge $646, right? $646 round to the nearest dollar, and then 28,328. 28. Okay, so that's my ordered pair. Okay, that's my vertex, right? So the revenue is the Y value, so that's 28,328, and the store should charge $646. Okay, so that concludes, chapter 4, section 6.6, and I think this is part 2. Let me see. Yeah, part 2. So there you go.